In this video, we are going to take a look at the thin film section of the standard surface shader. Thin film reproduces the effect of thin film interference on a surface, and the most obvious example would be to create a soap bubble material using thin film property. This effect occurs on very thin transparent surfaces that their thickness is approximately that of the wavelength of visible light, which is around 500 nanometer. Obviously, if you are interested in the physical aspects of this shader and how it works in real life, you can check out related articles on web. But for now, I'm gonna jump right in and start working and create some realistic looking bubbles and whatnot. If I run the IPR, in this scene, we have an Arnold sky that provides the HDRI lighting and a simple sphere that's gonna work as our soap bubble. You can see it has an Arnold parameter tag. It has a Catt-Clark subdivision with iteration set to 3 because we have some displacement mapping going on in the shader that is applied to the sphere. We will be talking about displacement mapping later on in this section. Also, in the material manager, you can see we have this shader network that I have named it thin film, and this is already applied to the sphere. And if I open it up, you can see we only have some basic displacement mapping set up just to make the sphere look a bit more organic. We have a displacement node with scale set to 0.1 and a simple procedural noise with scale value set to 2 as the displacement map, and this gives us that organic look on the sphere that you see in the IPR. We take an in-depth look at displacement mapping later on in this section. Now let's add a standard surface shader and connect it to the Arnold Beauty port. First of all, let's zero out the base weight so we can see the effect a bit better. Now in the thin film section, we need to increase the thickness to something more than 0. Let's try 250 nanometers. Also, to see the effect better, we need to set the IR value in the specular section to 1. And now as you can see, we get this beautiful thin film look. Now let's take a look at the thin film shader parameters. We have thickness min, and this is the minimum thickness of the thin film in nanometers. Basically, the coloring of the shader depends on how thick the thin film is. So let's try 50. So you can see because it's so thin, we have a monochromatic look. Let's go to 100. Still not much of a change. Let's try 150. And now we start to introduce some colors. Let's try 200. More colors, 250. So as you can see, based on the particular look that you are after, you can use a different minimum value. Let's try 300, 400, maybe 500, 600. In this case, let's use 250 nanometers. The thickness value affects the specular transmission and code components. Normally, this would be something like a noise map to give some variation to the interference effect. Let me show you how you can do that. Add a noise map to the network. Now let's connect the noise to the Arnold Beauty and increase the scale on all dimensions to 2. Now we can connect this map to the thickness value, and based on the grayscale value of the noise map, we are going to get different thickness values. But the problem is the noise output values from 0 to 1, but we need values like 250, 400, or 600 for the thickness parameter. So we need to adjust the output range of the noise node from 0 to 1 to, let's say, 250 and 500. I'm going to add a range node do that and connect the output of the noise to the input of the range. So the inputs min and max of the noise are 0 to 1. We want to adjust that range to, let's say, 250 to 500. So let's type in those values in the output min and max. Now connect the output of the range node to the thin film thickness value and use the standard surface shader as the root shader. Now, as you can see, we have created this beautiful thin film variation, and we can use different min and max thickness values in our range node. Let's say 300 to 700. And now we get a combination of 300 to 700 nanometer look, or we can go for a smaller range like, let's say, 250 to 400. Or I can adjust my noise node and get different looks. For now, let's disconnect the range node and set the thickness to 250. IOR here controls the refractive index of the medium surrounding the material. Now let's finalize our soap bubble shader. If the shader we are trying to apply the thin film effect didn't have any transparency, like mother of pearl for example, we don't need to change anything in the transmission section to make the material transparent. But in the case of soap bubble or similar shaders, we do need transparency. So in the transmission section, let's increase transmission weight to 1, and the specular roughness for bubble is normally 0. Also, let's increase the coat weight to 1 and zero out its roughness as well. Now you can obviously control the coat weight as you wish. In the thin film section, increase the thickness to 500. And for the soap bubble, we can use an IOR from 1.33 to 1.4. Let's try 1.4. And here is our beautiful soap bubble shader. So in this video, we'll learn about the thin film section of the Arnold Standard Surface Shader. See you in the next one.